Today, we're going to be discussing cumulative frequency graphs. When we did box and whiskers plots, we could find what was in the 25th percentile, the 50th percentile, 75th percentile, but we might need to know other percentiles. You might be familiar with this when you go to the doctor and they say you're in the 70th or the 80th percentile for height, or maybe the 57th percentile for weight, for example. They can calculate those given cumulative frequency graphs. Another name for these graphs are OGIVs, O-G-I-V-E. I don't know what that means, but that's what that's called, or I don't know where it came from, but it's a cumulative frequency graph. And the way you read that is, for example, if they have a group of kids in an area, maybe this is like a bounce park or something, or I guess that would be a little young. Maybe this is a movie. You could go to 14, and you would say about 70% of students or 70 students are 14 and under. So that's how you read that. So if you go to 14, go up, go left, 70 students are 14 and under, and that's how you read that. And if you go to 16, go over here. Oh, that is parallel. About 110 students are 16 and under. And that's how you read a cumulative frequency graph or an OGIV. So what we're going to do is plot the cumulative frequency curve for this data set that you have on your paper. So what we're going to first do is create cumulative frequency. And we've done this before. So we're going to create another column where we add up the number of students for each age. So what this means, so this stands for cumulative, this means we have 5 students, 10 and under. How many students do we have 11 and under? 15. Good. So to get that number, you take the number you had previously and add it, so we're accumulating the number of students. How many students do we have 12 and under? 42. Good. Good. 60? 66? 82, beautiful. 129. So one good thing about the cumulative frequency column is we know the total number of students that we talked to or sampled. So 129 students total. And at every level, I know there's, for example, 120 students 16 and under. There's 82 students 15 and under. So I know like 82 students couldn't drive, for example. But I also know that, 129 minus that could drive. So 38 plus 9. So it helps us to just have a sense of how many students are that age and under. So that's our cumulative frequency graph, or our cumulative column. And now I'm going to go into split screen so I can create the cumulative frequency graph. And so I've already put the labels on there for you. And so I have the age on the bottom. And so we can just label that. The only suggestion I have for you is to spread it out. So I'm going to do a lightning bolt, which is a break in the graph. And I think we can skip 1, so we can spread it out a little bit. Do you think we can skip 2, or do you think that would be weird? To spread it out, would we? 2? Okay. So 11. So I'm just counting out the ages of the people that were surveyed. And then we have cumulative frequency on the left. So we go from 5 to 129. I feel like I have to go up by tens here. So I can start at 0. I don't need a break then. I think I just have to go 10, 20, 30, 50, 60, 70, 80. Yeah. And I'm a little bit out of room. So I'm just going to do a little scooching my graph over would be bad. So maybe I'm just going to move my title a little bit. And then I'll move it back. So notice I put marks for every one, but I only numbered every 20 just to make it look a little neater. And again, the title on that side is cumulative frequency. That's what an OGIV or a cumulative frequency graph will always have on the left side. This is going to look pretty crowded, but I'm going to try and scooch it in there. So, yeah. Oh, I'm sorry. On your paper, it's super crowded too. Should have thought of that. My bad. It's okay. Okay. So at 10, we are at 5 students. So that's, we know, halfway in between 0 and 10. Right there. And then we can just keep going. At 11, we are at 15. 12, we're at 42. I'm going to stop talking because the numbers I'm throwing out might be distracting. Now, when you are done, you're going to want to connect the dots. I think I missed one. That's a bummer. All right, any questions? All right, so here I can just go to any age and find the number of people that are that age and younger. So without having to look at a table, I know 16-year-olds, 120 students are 16 or less. What might be more useful than knowing the number of students? Percent, yes, good, the percent. So what I can do then is calculate the relative frequency. Now the relative frequency we talked about early on in the statistics chapter, that's just the percentage. In your text, it has shown it both as a percent and as a decimal. I like it as a percent better. We know the total is 129. So to calculate the relative frequency, you're just doing the number of people in that category divided by the total number. And then because it's percent, what do we multiply by? 100. Thank you. So here, you're kind of skipping over the cumulative frequency column for this calculation. And because it's a percent, you're doing per 100. And I'm going to count on you to give me the actual amounts. So, and then if you're done, to calculate the total too, because what should the total be if I added up all the percentages? You are on it. Oh. Just the frequency. So my eraser stopped working, so that's fun. Okay. All right, we're getting there. Let's see, 38 out of 169, then we have 9 out of 1. Why do I keep writing 169? 129. And let's erase, erase, erase. Yeah. Okay, and then times 100 because we're doing percents. So, who would like to hit me with the percents?
I got them all in here.
Okay.
That was 14. Thank you. Oh, that's a percent.
Yeah, I think you're adding another number.
4.7. That's 4.4. I got. Or that 4.5. Which one? 6.8. 9.
Okay, did anyone try adding?
It's 28.
Did anyone try adding? Okay, cool. And what did we say it had to add to?
What?
Well,
Yeah, it's well, I got 3.2 because I got it.
yeah, you because all these have been rounded, it will be unlikely to have 100% exactly. So you should be in the neighborhood. You got exactly. Okay. Good job. Right. So that's a relative frequency. So you can have also your y-axis be a relative frequency graph. Any questions? Okay, so let's take a look at this. We're going to construct a cumulative frequency distribution table. represent the data on a cumulative frequency graph, and use the graph to estimate the following. So this is where we actually have to synthesize the data, not just calculate it. So let's do this. Okay, I'm going to go side by side, and let's work together. So what I'd like you all to do is construct that table. Okay, so let's add cumulative frequency. Let's do that first. So we can just scooch over. I think I gave you room to the right. Cumulative frequency.
Are we right?
We will be.
Oh, got it.
All right, so construct a cumulative frequency distribution table. So that's just adding a column that says cumulative frequency. And so let's do that. And then we're going to do a cumulative frequency graph. And I forgot to read what this is. This is the result of this women's marathon. Holy cow, these times are fast.
Wow.
So, yeah, so we have between 2 hours and 26 minutes to 2 hours and 56 minutes. That would take, I mean, I don't know what I could do in that amount of time, but that's an entire 26 miles. Holy cow. Okay. All right, so I'd like you to do the cumulative frequency. I will walk around while you do that. So for cumulative frequencies, we know runners that got between 2 hours, 26 minutes, but less than 2 hours, 28 is 8. What's our next number, everybody? Done? Done? Okay. What's next?
43.
Done?
55. 65.
Okay, that was a lot, but we got it. Good job. Okay, so these numbers should always do what? They should always go up. We're always adding each time. All right, let's create a cumulative frequency graph. Okay, and I'm out of graph paper, so I apologize. You might just want to grab a piece of loose leaf. So I'll do it freehand to show it can be done. So what are we going to write on the bottom? What are we studying? So marathon times. (2008) Olympics. Women's. Because it won't be anywhere close to 0 to run 26 miles, we'll put a break in the graph, and our lowest time is 2 hours and 26 minutes. So I'm going to give you a half because all of them say 2 hours. I'm going to write time after 2 hours here. In minutes. So this would say on the graph, all I'm going to write is how long it took them to finish after the 2 hour mark. And I'm also going to give the units, which is in minutes. So you have to specify that it's in minutes. So the lowest or the fastest time was 26. And then we're going to go by 2s. I think that would make sense here because all of the left side is in 2s. So we have to get to 48. Not feeling great about that. So, yeah.
So does that mean that you can just take the whole chunk and just make that your thing or what? It goes from 2 to like 8, and keep it 8, you know?
Yeah, so that's a good question. So at 28, I'm going to graph 8. At 28, I'm going to graph 8. But I have to start at 26 graphing 0 because no one finished. Well, maybe, I mean, basically I have to start from 26 to 28 with my 0 starting at 26 is kind of a minimum time. But I do have to get to 56. So, ooh, yeah. So what I'm going to do is kind of just scooch this whole thing over. This might be a little bit. So my 28, oh, there we go. Okay. And then I might do like 56. Oops, kind of like 50, 52, 54, 56, kind of like that. Not the best job I've ever done, but there it is. And then the left side will say frequency. And then I feel like I should go up by 5 because I only have to get to 70. So the left side should say cumulative frequency, or I could say, yeah, cumulative frequency. Let's do that. This is very quick. Erin, can you chill out with that? Cumulative frequency, written as small as possible. And I think I can go up by 5s, but I'm only going to number the 10s just to keep my spacing nice. So I'm not making this look super crowded like I did my bottom of my graph. Okay, so at 28, we had 8. 2 hours 28, we had 8. At 30, we had 11. We can just keep going. 32. So I just want to point out that this is what I'm graphing, and this is what I'm graphing. This is my X, this is my Y.
Oh, yeah.
Wait, so what do we do for the whole thing, the gaps? You just go to the end of it? You just go from 40 to 48, mark by 63.
Yeah, I just numbered. If I had room, I would put 50, 52, 54, and then 56. And then at 56, I graph the 69. And you have to use the second part of the finishing time, because what you say is 69 people, 69 women ran a time of 2 hours 56 or less. That's why you have to use the second number in the range instead of the first. And the graph always go up because it's adding. And the convention is to start the lowest time at 0 people or 0 data points. I guess someone could get 2 hours and 26 exactly, but that's kind of the convention of it, that you start your lowest at 0. So that's why I started that on the horizontal axis there. Questions on the graph? Okay, let's go to the questions then. So I'm going to scooch this over. And I'm going to look. Use your graph to estimate the median finishing time. So median finishing time, so for CI, the median, how many people do we have? $69 people. So who is the median person, or the person in the middle? The person that finished in the exact middle of the wave of women. How do we calculate that? Well, okay, so what we get is 34.5, so which is approximately the 35th person. So the 35th person to finish would be the person that beat 50% of the runners. So they were right smack dab in the middle. So what they want to know is, what is the median finishing time? So that's where the graph fills in really well. What you do, this is the person, okay? The people are on the y-axis, okay? The times are on the x-axis. So what you're going to do is go to 35 and then go down. Did anyone else get about 35 minutes? That is funny. It is a huge coincidence. So this person got 2 hours, approximately 2 hours, 35 minutes on their marathon. That is a huge coincidence. This really could have been any time. So you have to keep clear what you're talking about here. This is the 35th person. What time did that person get? So are we looking for the time, or are we looking for the person? That can be tricky. Yep.
So we're not going to use the cumulative frequency to find out if it lines up on the table?
So that would give you the range. This graph kind of pinpoints where, and what we're trying to get now that we know about these graphs is for us to use them.
Because I was wondering, because like if we use the table as the previous lesson, it would have been like too bad. So.
Well, the 35th person would be somewhere in this range here, right? Because this goes to 31 people, this goes to 43.
Okay. Yeah.
So it would be somewhere in here. So it still would track, and it would be a similar answer that way. Okay, let's do it. Number 2, the number of competitors who finished in a time less than 2 hours and 35 minutes. So let's look at that one. Okay, so let's look at 2. What percent would that be? Less than percent. The number of competitors who finished in a time less than 2 hours and 35 minutes. What's that? Well, we can. So you said 35 times 69 times 100? Nope.
Can you just add up the people that are below that one and then just divide by 69? And then multiply by
If you do 35 divided by 69 times 100, it's
50.
So it's 50%.
It's 50%. Yeah, so this, we discovered that this is kind of the median, right? For 2 hours, 35 minutes.
Yes.
So if we're at the median, how many people are below the median? 50%, which is how many people? About 34. Because we have 69 people. Half of 69 people is 34.5, which just means the 35th person is standing there in the middle, or not standing, she's running across the finish line. 64 people finish before her, 64 people will finish after her. So about 34 people took more than her, and 34 people took less. So we know that that's the median because of part 1. Then for 3, they want to know percentage of competitors who took more than 2 hours and 39 minutes to finish. So 2 hours, 39 minutes is a time. So I go to the time part of my graph. Here's 2 hour 39. I go up. And on graph paper, this would be way better. I would go over. 53. Yeah. Look at your graphs. Go to 39, go up, and go over. Go ahead. Look at your graphs. Go to 39, go up, and go over. I want to know what time you get. Because this is where the mode is great. Because we have a bit of a consistency, we can go with that number.
So can you just read it 39 divided by 69 and then multiply by 100?
We want to know who took more, so we're taking that number minus 69. What did we get for the number here? What did you guys get? What did you get? Yep.
Like 49.
You got 49. What did you get? 50. What did you get? 53. 56. What did you get, Bryn? 53. Aaron? 53. What did you get, Lorette? What did you get? Okay, looks like 53 is our median. So if 53, did 53 finish under this time?
Yes.
Yeah, so 53 finished under this time. 53 finished under this time. So how many finished over? So 53 were under the time. So how many would be over? 16. 16 took more time. So we do 16 over how many? 69 times 100. And the only reason I went with 53 is because it was the more popular answer. If you want to go with yours, go with yours. Okay. And again, if you use graph paper, the answer will be more accurate. And what did we get? 16 over 69 times 100? 23%. And then lastly, the time taken by a competitor who finished in the top 20%. Top 20. How many competitors were there? 69. So it's 69 times 20%. What did we get there? 13.8. So 14 people. So 14 people. Let's look at our graph. 14 people. 14 people on my graph is about right here. Let's go over here and go down. God. Yeah, it has to be above 30. I feel like my graph's a little messy. Maybe 31. Did anyone else get around 31? 31. So this would be 2 hours, 31 minutes. And if it's approximate, you can put that little wiggly saying you're not sure. So if you were in the top 14 runners, you were in the top 20%. And the way I calculated that is 69 times 20. That tells you how many people are in the top 20%. Questions? There's a graph. Here is the assignment. It's so tiny. Let's view it big. This won't be assigned at all for homework. This is in-class work for tomorrow.